Okay, so today I'm going to walk you through planetary wind belts. All right, so first things first, wind always blows from areas of high pressure to areas of low pressure. All right, remember, in areas of high pressure, air is going to sink. That's like if you push your hand down into the desk, that would replicate sinking air. So it's pushing down, it's high pressure. And it's going to move away from the area where it's sinking. So think about it, it sinks down, hits the desk, it's got nowhere to go but away from that spot. So high pressure air is sinking and moves away from the center. Low pressure air is going to do the opposite things. So it rises and it moves towards the center. Okay, so knowing that, now you have the tools to actually fill out or create a diagram such as this. And so this is the Earth. Lines of latitude are labeled here, so from 0 to 90 degrees north, 0 to 90 degrees south. And you also see what's going on with major atmospheric winds in terms of convection cells. Is the air rising or is it sinking? Okay, so just to make this a little bit easier, what I'm going to do, I'm going to turn the paper, and now it's going to be a little bit more clear, I hope, to see that air along 0 degrees, also known as the equator, is rising. Right, so that air is rising up until it hits the top of the troposphere, that's the lowest layer of the atmosphere, hits the layer known as the tropopause, and then it basically spreads out. Right? So it hits that top layer, like air hitting the top of your ceiling, or bottom of your ceiling, and then it'll spread. And then when it gets to about 30 degrees south and 30 degrees north, that warm air from the equator has cooled down enough that it's actually going to become dense enough to sink. All right, so we have sinking air at 30 degrees north, sinking air at 30 degrees south. Okay, so what I'm going to do is just go ahead and finish with these convection cells in the upper atmosphere. 60 degrees south, that air is also rising. So it's going to spread away from 30 or 60 degrees south. It's going to go up towards 30 south and down towards 90 degrees south. It's going to do the same thing in the northern hemisphere. Air is rising at 60 north. It's going to move towards 30 north and up towards 90 degrees north there. Okay. The next thing I'm going to fill in is what's going on the surface. So everything I've drawn, every arrow I've drawn so far is an upper level atmospheric wind, not something that we really experience on the ground. Okay, so we're going to focus in on what happens on the ground here. So at 30 degrees north, we have sinking air. Remember, sinking air is high pressure, and then the air moves away from that. So air here, the winds are going to go from 30 degrees north down towards the equator. They're also going to spread northwards towards 60 degrees north. Okay, at the North Pole, we have sinking air. So air is going to move from 90 north down to 60 degrees north. Okay, so a couple things to notice here. Where we have surface winds coming together or converging, we have air rising. All right, that creates areas of low pressure. Where we have surface winds spreading apart or diverging, we have air sinking. That creates areas of high pressure. All right, so we have high pressure at 30 degrees north, high pressure at 30 degrees south, and high pressure at the poles at 90 south and 90 north. In between the areas of high pressure, we have areas of low pressure. So it's low pressure at 60 degrees north, then high pressure at 30 north, it's going to be low pressure. And we just double check that. Air at the equator is rising. We're going to find that the surface winds do indeed converge. They come together at the equator, forcing air upwards, creating that low pressure. Okay. So within 5 minutes, you've just drawn in global atmospheric circulation, right, which is responsible for planetary winds. And some additional details that you wouldn't be expected to know for a Regents Earth Science course, but I'm going to tell you anyway. There's 3 types of convection cells that are kind of on Earth. The cells between 0 and 30 degrees north are known as Hadley cells. So there's a Hadley cell in the northern hemisphere as well as in the southern hemisphere. The cell in between 30 north and 60 north is known as a Ferrel cell. It's F-E-R-R-E-L cell. And then the cells at the very top are simply known as polar cells. Okay, again, not information that you would ever need to know on a Regents exam, but it's just extra information for you. Okay, so this is what's going on in the kind of upper atmosphere. Again, not so much of importance to our day-to-day lives, and other than the fact that it's responsible for creating pretty much all the weather on Earth, but you don't really feel the effects of it. You feel the effects of surface winds much, much more. Okay, so the remainder of this video, I'm going to show you what's happening with the surface winds. So these winds that I drew right along the surface of the Earth. I'm going to use the remaining space over here to kind of show you what happens with those winds. Okay, so we know that the winds are coming from 30 north towards the equator and up towards 60 north. But they don't simply go in a straight path like this. All right? So surface winds don't move in straight lines. If the Earth didn't rotate, they would go in straight lines. But our Earth is, in fact, spinning on its axis. Because of that, we experience something called the Coriolis Effect. All right? So basically what happens here, in the northern hemisphere, instead of having a straight line from 30 north down to the equator, those winds are going to curve. And they curve in that direction. Okay? I'm going to show you one more time how this happens. But now what I'm going to do is flip the paper over. So if this is your starting point, the winds actually appear to curve towards the right. So in the northern hemisphere, winds will curve or deflect to the right due to the Coriolis effect. Same thing happens between 30 north and 60 north. The curve to the right there is much more easily seen. Same thing happens at the poles. So those winds are also curving towards the right there. Okay. From 0 degrees the equator and 30 south, similar thing is going to happen. We have winds that are moving from 30 south. Again, Earth didn't rotate. It would be a straight line. But the Earth is, in fact, spinning, rotating once on its axis every 24 hours. But in the southern hemisphere, winds deflect towards the left. Okay? So instead of deflecting towards the right like they do in the northern hemisphere, winds in the southern hemisphere deflect towards the left. So I'll show you what that looks like going down towards 60 degrees south. And I'm going to flip my paper. This is our starting point. Deflection towards the left is that way. Okay. So again, the surface winds are the solid blue lines that I've drawn in between the lines of latitude. Last one, from the poles towards 60 degrees south. Okay, so these winds are extremely important to weather on the planet, as are the atmospheric winds. And we'll talk more about them when we talk about weather, and that'll be our next unit of study. Okay, so within about 9.5 minutes here, we just took something very complicated and boiled it down to the diagram that you see here. Okay, so there's some YouTube links in the slideshow. Hopefully you find them useful.